this video, we're going to explore how to solve polynomial inequalities. Due to the complex nature of polynomials, you actually have to solve these kinds of inequalities a little bit differently to how you would solve linear inequalities. For those who don't know me, my name is Chris Iannazzoni. I used to work as an engineer for a defence company, and I've since left that to start a career in tutoring. I make these videos so that VC students can do the best they can in math methods. With that out of the way, let's get into it. The easiest way to solve a polynomial inequality is to first sketch the graph, and then use that graph to help you solve the inequality. We'll use the following framework when it comes to solving these questions. All the challenges of this topic are focused around the idea of sketching the polynomial. So if you need to revise how to sketch polynomials, then feel free to click the link above to do a bit of revision. Otherwise, let's look at an example. The first step is to get all the terms of your equation onto the same side, and in this case we're left with a quadratic that is less than 0. The next step is to sketch that polynomial. Our polynomial is a quadratic, and this one in particular doesn't have any easy to find x-intercepts, so we're just going to rely on the quadratic formula to find those x-intercepts. When sketching, we usually also have to try and find the y-intercept as well as the turning point. When it comes to these kinds of questions, those qualities are technically optional. The only things that are mandatory is where the x-intercepts are and if you have a positive or negative parabola. In this case, we have a positive one, since our x squared term is positive. Now comes the interpretation of the graph. The y-axis can be broken down into two separate sections, the positive half and the negative half. If you're looking for your function to be greater than 0, then you're looking for where the y values are going to be positive. In this case, that would mean that you would want all the x values that are either side of the x-intercepts, since that's where the graph is positive. That's where all those y values are positive. But we're not looking for that. We're looking for where our function is less than 0, in which case we're looking for all the negative y values. Hence, we're just going to look at our graph and identify where is the graph negative, and in this case we can clearly see that it's between the x-intercepts. If you found this video helpful, then you should consider joining my free community. I host a Q&A call every week to personally help you through any of your specific questions, and you'll also get access to more resources like this, including written and recorded lecture content, as well as practice exams and SACs with detailed solutions. It's pretty cool, you should check it out. I'll see you there.